Question 5 is the lowest common multiple question. They want you to find the lowest common multiple of 8 and 12. Now there's two methods to do this. There's a very simplistic one which lists the multiples of 8 and lists the multiples of 12 to find the lowest number that they both have. So let's do that first. 8, 16, 24, 32. I'm going to stop there and just do my 12s. 12, 24, 36. Oh, hang on a second. There we have it. The lowest number in both times table is 24. Now that's enough to get you the full marks. However, you could always use a cherry picking process if the numbers aren't so nice, or if it's asking you to find the highest common factor as well as the lowest common multiple. A reminder of that method is to break it down into its prime factors. So how can you get 8? Well, one way of getting it is 2 times 4. 2 is a prime. I'm going to circle it. How do I get 4? 2 times 2, prime, prime. So I can write 8 as a product of its prime factors. 8 is 2 times 2 times 2. Now I'm going to do 12, and I'm going to do 2 and 6. 2 is prime, so I'll circle it. 6 is 2 times 3, prime, prime. So I can write 12 out directly underneath it as 2 times 2 times 3. Now at this point I need to find the highest common factor. In order to do that, I take the common numbers in the top and bottom lists. So there's a 2 and a 2 there, and there's a 2 and a 2 there. I take those and multiply them together. So that 2 and that 2 gives me a highest common factor of 4. Now I can of course take the ones that go across if I wanted. They do not have to be on top of each other. There just needs to be the same amount of numbers in the top line and the bottom line. So that gives me a highest common factor of 4. Lowest common multiple is actually the HCF times by the leftovers. And we found the HCF to be 4. Our leftovers are that 2, which hasn't been used, and that 3, which hasn't been used. So that'll give me 4 times 2 is 8. 8 times 3 is 24. That then gives me the same answer. Now, this is a really complicated method when you could be using that. So my advice is to stick to that. You get 1 mark for your method and you get 1 mark for your answer. Question 6 is an interior-exterior angles of a polygon question. Interior and exterior angles of a polygon is something that you're going to need to learn. So look it up, watch the video clip, learn it because it's in pretty much every exam. The diagram shows 3 sides of a regular polygon. Regular, all sides are equal. Polygon is a shape with a number of sides. Each interior angle of the regular polygon is 140 degrees. Work out the number of sides of the regular polygon. So we know the interior angle is 140 degrees. Now, in order to make a link between number of sides and angles, we need to know what the exterior angle is. Now, don't be tricked into thinking the exterior angle is going to be all of this. It's not. The exterior angle forms a straight line with the interior angle, and they total to 180. So first stage of working out is going to be that an exterior angle is equal to 180 degrees minus the 140 degrees interior angle, which leaves us with 40 degrees. So I know my exterior angle is 40 degrees. Now, in order to find the number of sides, I know that that's 360 degrees divided by my exterior angle, which is 40, and that's going to leave me with 9. sides. I can't break this down any more for you because it's a matter of knowing the rules. You need to know the relationships between interior angles, exterior angles, and the number of sides a polygon has. With regards to the mark scheme, you get 1 mark for finding the exterior angle. You get the second mark for taking whatever you believe the exterior angle to be and doing 360 divided by it. And then you get your final answer mark at the end. Question 7 is a formula question and substituting into formula. It then goes on to graphs and using graphs. You can use this formula to change a temperature in centigrade to a temperature in Fahrenheit. And there's the formula there. Fahrenheit equals 1.8 times by the centigrade, and then you add on 32. Then it says use the formula to change 20 degrees Fahrenheit into, change 20 degrees centigrade into Fahrenheit. So I know, because they've given me a centigrade amount, I need to substitute that in instead of the C. So my Fahrenheit equals, and because this is a multiplication, I'm going to put it in a bracket. It's 1.8 times C, and we know C to be 20 degrees centigrade. And then once I've done that, I add the 32 on the end. So Fahrenheit actually equals 1.8 times 20. Sounds a little tricky, but when you consider that 1.8 times 10 would be 18, and then you double that, it's going to be 36. And then when you add your 32 on, that gives you a temperature of 60 degrees Fahrenheit. So on the answer, 68 degrees Fahrenheit. Now, on the grid opposite, you need to draw a conversion graph that can be used to change between temperatures in centigrade and temperatures in Fahrenheit. Now, because the two variables I'm dealing with here are centigrade and Fahrenheit, that's what I expect to see on my axis. And there's my graph, and it's got centigrade going down the bottom and Fahrenheit going up the top. Now, I need to actually draw this conversion graph. In order to draw a conversion graph, I need some points. And in order to draw a straight line, it's worth remembering that you only need 2 points. Because once you have 2 points on a line, you can connect them and extend your line, and that'll give you a full graph. So I've already got the point that centigrade and Fahrenheit, I'm going to make a little table so I'm organised. 20 degrees centigrade, I found out above, is 68 degrees Fahrenheit. Now, I'm going to work out what 0 degrees centigrade is. So when the centigrade is 0, Fahrenheit is going to be 1.8 times 0, add 32. 1.8 times 0 is 0, 0 add 32 equals 32. So I know 0 degrees centigrade is worth 32. I'm also going to go ahead here and find out what 10 degrees is. Even though I only need 2, I'm going to do it just to check all my points fall on the same line. So my Fahrenheit, when C is 10, is 1.8 times by 10, add on 32. 1.8 times by 10 is 18. So 18 add 32 is going to give me 50. So 10 centigrade gives me 50 Fahrenheit. Now I've got plenty to be plotting there, so I'm going to plot these 3 points and hope they're all on a line. So here's my graph. Let me zoom out. My first point I'm going to plot will be 20 and 68. So 20 centigrade along the bottom, and it goes up to 68. So there's 60. And this graph, I'm going to zoom in and show you, it's got a bit of an awkward scale. I want 68. There's 60. and there's 70. And it gets from 60 to 70 in 1, 2, 3, 4, 5 increments. That means each little line is worth 2. So that's 62, 64, 66, 68, 70. Don't let the axes of a graph make you lose marks just because you've not been paying attention. So 20 degrees centigrade goes up to 62, 4, 6, 8. There's 68 degrees Fahrenheit. Then I'm going to plot my 0, and I found that 0 degrees centigrade is 32 Fahrenheit. 0 centigrade is 32 degrees Fahrenheit. And I'm going to plot my third on, and that's 10 degrees centigrade, which is 50 degrees Fahrenheit. So 10 centigrade, 50 Fahrenheit. Now I'm going to take my ruler and join these 3 points and hope they're all on a straight line. Yes, they are. Fantastic. So I'm going to draw a line straight through that. Now that is my conversion graph, and anywhere along this line that you choose to pick a temperature in centigrade, you can draw up, read across, and that'll give you your degrees in Fahrenheit. Now, as if by coincidence, part C says to use your graph. Now the fact that it says use your graph, you need to show them that you're using the graph. Put your lines in. And also the fact that it says use your graph means that if you've drawn your graph wrong, but your answer reflects what you've got on your graph, you're still going to get the marks. So use your graph to change 100 degrees Fahrenheit into centigrade. So I'm going from Fahrenheit to centigrade. So I need to go from 100 degrees Fahrenheit, which is there. So I'm going to, in a different colour, read across from my Fahrenheit to my conversion graph line, and then I'm going to bounce that down and work out what that is in centigrade. And I'm going to read that temperature there. This does not, down the bottom, this doesn't have the same scale. There's 10 there, so each one is worth 1, so they've been really tricky. So that's 35, 36, 37. Well, I get 38 there. So my answer is going to be 38 degrees centigrade. Now, you are allowed to have anything from 36 up to 39 because they're going to allow any account for your graph being slightly inaccurate. Question 8 is an area question. Mrs. Kuhnel's garden is in the shape of a rectangle. Part of the garden is a patio, and that's in the shape of a triangle. The rest of the garden is grass, and that's labelled up nicely for us. Mrs. Kuhnel wants to spread fertiliser over all of her grass. 1 box of fertiliser is enough for 32 metres squared of grass. I'm just going to write here that 1 box equals 32 metres squared of grass. How many boxes of fertiliser will she need? You must show your working. So the end of my question is going to be how many boxes she will need. Alright, so in order to work that out, I need to find first of all the area of the grass. This is a really difficult shape to find. The grass. In order to make this easy, first thing I'm going to do is find the area of the full garden. Because that's a nice easy shape, that's a rectangle. So the area of the full garden is base times height, and its base is actually written on top there, that's fine, it's width, and that's 12 metres, times by its height, which is 7. And 12 times 7 is 84. And we're dealing in an area, so it's 84 metres squared. Now, in order to find the area of the grass, I need to find the area of the patio. And it's a triangle, so it's half base times height. So it's half, the base is 6, times by the height, which is 3. Now 6 times 3 is 18. So half of 18 equals 9 meters squared. So my whole garden is 84 meters squared. My triangle patio is 9 meters squared. I can now find the area of the grass by doing my whole garden, take away the patio. So that's 84 take away 9 is going to leave me with 75 meters squared. So that's how much grass I've got. Now, because I know that there's 75 meters squared of grass, and I need to know how many boxes, I need to take the area of my grass, which is 75 meters squared, and I need to divide it by the 32 meters squared that one box covers. And that's going to give me my number of boxes. Now straight away I can see that that's a really difficult calculation. If this was a calculator paper, you would have to calculate it accurately. However, it's a non-calc paper, so I can be quite tricky about this if I want. I know that one box is going to give me 32 meters squared. I know that 2 boxes is going to give me double that amount, so that'll give me 64 meters squared. Now I need 75 meters squared, so 2 boxes isn't enough. Let's have a look then how much 3 boxes will cover. So that's add another 32 onto that, is going to give me 96 meters squared. And I can see straight away that then takes me over 75 meters squared. Now the reason this is a good enough working out is because I only need to know the number of boxes required. I don't need to know the decimals. I do need to be careful, however, that I don't think, oh no, that's too big. I don't need that much. I only need 2 boxes. No, you need to make sure that you have enough to cover the grass that's there. So 2 boxes isn't enough seed. You have to buy 3 boxes. Therefore, you can give your final answer that she needs 3 boxes. Now, with regards to how the marks are distributed for this, it's a 4-mark question. You get 1 mark for finding the area of your shapes, or at least one of the shapes correctly. You get your 2nd mark for doing the subtraction to find the area of the grass. You get the 3rd mark for showing how you're going to get to the number of boxes you need, and you get the 4th answer mark for getting the 3 boxes correct.